All right, welcome to another episode on Prime Logic. If you want to solve this problem, please pause the video because I'm going to solve this problem right now. So the problem setup is pretty much self-explanatory. So we have two right triangles which are located on the same base, right? So this right triangle and this right triangle. So your job is to find the value of this side of this right triangle. So on the left side, two sides are known, right? So we have 8 and 6. So obviously we can find the hypotenuse here using the Pythagoras theorem. But from this right triangle, only the hypotenuse is known. So we don't know this side and we don't know this side. Our job is to find the value of x, which starts from here all the way to here. So I think it's very clear that we need to start from the left triangle. So let's find out the value of the hypotenuse using the Pythagoras theorem. So we can say that, so let's denote some names here. So A, B, C, D, and E here. So we can say AC squared equals AB squared plus BC squared. So let me write it down here. AC squared equals AB squared, which is 8 squared, plus BC squared, which is 6 squared, which is 36, right? So this gives us as 100, and AC equals square root of 100, which is 10. So the hypotenuse here on the left triangle, it is just 10 units. So now that we found this part, now we can go with the next part and just find and solve all the way through the next step. So let's work on the exterior angle here. So this angle is obviously 90 degrees. If we name this angle, so let's just name this angle as theta, right? So this exterior angle, this whole thing, like 90 degrees plus theta. According to the exterior angle theorem, so it equals to the sum of two interior angles. So these are the ones that are remote, right? So 90 plus theta equals this one plus this angle, right? So 90 plus theta equals 90 plus something else. So this something else must also be theta. So according to this exterior angle theorem. So if this angle is theta, this is also theta. So this one is a right triangle, 90 degrees, 90 degrees. So two angles are the same in two triangles. So these two triangles must be similar. So these two triangles are similar. So we found theta to kind of prove that these angles are the same and these two triangles are similar. Now we can write down this proportion relationships and the corresponding sides so we can compare them and find x. So from the left triangle, the corresponding side of AB to this triangle is CD, right? So we can write down here as AB over CD, which is x. That's the side that we want to find. So let's compare the hypotenuse now. So we can say 10 over 18 or AC over CE, right? So let's now just substitute AB, which is 8, AB 8 over CD, which is x, so that's the part that we want to find out, equals hypotenuse, so AC, which is 10 over 18. So let me just write it down here, x equals 18 times 8 over 10. We can just simplify that, so it is 18 times, so let's divide it by 2, 5, and it is 4. So 4 times 18 is 72, over 5. And that's the final answer. So x is 72 over 5. So your bonus challenge is to find the value of ED using the same relationship. I'm not sure if that's the only way to find and approach this problem, but if you have any other solutions, methods, comments, please make sure to write it down in the comments below, and see you in our next video on prime logic.